Find the probability that a randomly selected card from a standard deck of 52 playing cards is a king or an ace. Okay, when you read this problem, we want to look for key phrases first. So it's clearly a probability question. Then say the probability that a randomly selected card, that's just one card, right, from a standard deck of 52 playing cards is a king or an ace. All right, so the fact that they're asking me to find probability, the fact that they're only selecting one card, and the fact that we have the word or present in the problem indicates that this is an addition rule for probability problem. When I go to work out the problem, then I should fill in the formula that says the probability that we have a king, the first thing, right? Or the probability that we have an ace. Now, if I'm filling out the formula properly, I should take the first guy and say probability of that, probability of a king, plus the probability of the second one, which is the ace, minus the probability of, and I'm supposed to put in this category an overlapping scenario. So I want to blend these two categories together. So I want to say probability of getting a king that is also an ace. All right, so let's think about that category. Is that category possible? Are there any kings that are also aces? I don't think so, right? A king is just a king, and an ace is an ace, right? The ace is the card with the little A on it, and the king has a little face and the guy with the crown on it, right? So that's not the same card. They never appear together on one card. You're either a king or an ace. You cannot be both. So these categories are what we call mutually exclusive. They do not overlap. There's no intersection. So we're going to say the probability of getting that category is 0, and we can drop that part of the formula and just focus on these two parts, right? All right, very good. So it's always nice when it's mutually exclusive because we don't have to worry about that last fraction. That means we can solve the problem by just adding the probability that it's a king to the probability of an ace. All right, so in order to do this, then, we always have to say what? Number of, right? In this case, number of cards that are kings. And here we'll say number of cards that are aces, right? And of course, both of these will be over the grand total, the total for the problem. Okay, so let's look at the first top of the fraction here, number of cards that are kings. Well, hopefully you know something about a basic deck of cards. Essentially, for every type of card, there's always 4 of that type, because there are 4 different suits. So when we say number of cards that are kings, there will be 4 kings. It says that the deck has 52 playing cards in it, so the total is 52. You'll add to that the number of cards that are aces. So like I said before, in any set of playing cards, there are 4 cards of each type of card. So if I said the number of cards that are aces, there are going to be 4 aces. That would be the ace of diamonds, the ace of hearts, the ace of clubs, the ace of spades. And then finally, we divide by the total. The total there is going to be 52. Again, adding these together, same denominator, so add the numerators, you end up with 8 over 52. Both of these can be reduced by 4. 4 goes into 8 twice, goes into 52 13 times. You end up with 2/13, or if you want to know what that is as a decimal, you can simply divide the two numbers, and you end up with 2 divided by 13 is basically 15.4%, essentially. 15.4%, or 0.154 as a decimal.